Welcome to today's Explainer. Today is July 20, 2026, and well, the poetry of that date really shouldn't be lost on anyone here. Exactly 57 years ago today, Apollo 11 first touched down on the lunar surface. So today, we're embarking on a fascinating spatial voyage of our own. We're going to retrace the monumental steps of the recent Artemis II mission. We'll dive deep into the engineering triumphs and the very real human stakes of our return to deep space, all while exploring humanity's enduring connection to our closest celestial neighbor. Let's get into it.
I want you to imagine, just for a second, standing on the cratered surface of the moon and looking back. What exactly would you see? Well, as captured by the Artemis II crew, you actually wouldn't see that giant, vibrant blue marble we're so used to from classic Apollo imagery. Instead, Earth appears as just this thin, delicate, glowing crescent against the absolute pitch-black void of space. It's a breathtaking, super rare view that completely flips our everyday perspective, you know? It really reminds us of our precarious, brilliant little place in the universe, and honestly, it sets the stage perfectly for the sheer scale of what humanity just accomplished.
Okay, let's dive right into this. Section 1, the Artemis II mission.
Now, the absolutely crucial point here is the sheer magnitude of the gap between these two milestones. 1972. That was the very last time a crewed mission fired its engines for the moon. I mean, that is a massive, multi-generational drought in human deep space exploration. To put that 54-year gap into perspective for you, the guidance computer on those Apollo missions had roughly 100,000 times less processing power than the smartphone sitting in your pocket right now. Seriously, yet they made it work. And earlier this year, in 2026, Artemis II finally broke that drought. They became the first crewed mission to fly around the moon in over half a century, bridging that analog past with our digital present. It's a monumental return for humanity.
And the entire endeavor took exactly 10 days. 10. That number represents the total duration of the Artemis II journey around the moon and back. But let's really contextualize what those 10 days actually meant, because this wasn't just a quiet, peaceful drift through the cosmos. No way. This was 4 human beings living and working in a pressurized volume roughly the size of 2 minivans, traveling farther into the harsh radiation environment of deep space than any human has gone in 50 years. 10 days of flawless, incredibly high-stakes execution where literally every single breath is a triumph of modern engineering.
And that brilliantly illustrates what the crew was actually up to during that time. Artemis II was never just a scenic joyride, right? It was a rigorous, highly calculated shakedown cruise. The crew spent those 10 days aggressively testing the Orion spacecraft's limits. They weren't just checking boxes up there. They were evaluating vital environmental control systems, they were stress testing the carbon dioxide removal tech, and monitoring deep space radiation shielding in real time. By actively pushing these critical life support systems to the absolute brink, they generated the exact telemetry we needed to pave the way for our future permanent lunar outposts.
Moving right along to Section 2, a harsh, ancient landscape.
384,400 kilometers. That's the distance, in kilometers, from the Earth to the Moon. Now, anyone who follows space already knows this number, but let's talk about what 384,400 kilometers actually means for the Artemis II crew on a practical, psychological level. Orbiting at that massive distance means there's a multi-second communication delay with mission control in Houston. You can't just have a snappy, real-time conversation, but more importantly, it means there is no quick rescue. If something goes wrong out there, you are entirely on your own. Truly understanding that immense gulf of space is how you grasp the sheer isolation and the incredibly high stakes of this whole mission.
And once you actually cross that gulf, you're met with brutal extremes. Now, what's really interesting about this is how the moon has almost no atmosphere, meaning there's absolutely nothing to trap or distribute temperatures. So, as a spacecraft moves from the light into the dark, it transitions instantly between blistering sunlit heat that can literally boil water and freezing shadowed cold that dips all the way down to minus 170 degrees Celsius. To survive this, the Orion spacecraft had to perform what engineers affectionately call a barbecue roll, basically slowly spinning the capsule to evenly distribute those extreme thermal loads across its hull. It's a stunning feat of thermal engineering, and it's required just to operate in such an unforgiving environment.
And because there's no atmosphere, there's no wind, no rain, and no weather to ever wash the past away, this airless world acts as a flawless, silent time capsule. When scientists look at its stark surface, they aren't just seeing dead rock, right? They're looking at billions of years of cosmic impacts, perfectly preserved. It's a literal cratered record of the early, violent days of our solar system, just frozen in time. And actually, this is exactly why future Artemis missions are headed to the lunar South Pole.
Scientists are hoping to crack this time capsule open, extracting ancient water ice that can not only reveal the secrets of our solar system's origins, but actually fuel our deeper pushes into the cosmos.
Bringing us to Section 3, Earth's constant companion.
Despite sitting hundreds of thousands of kilometers away, the moon's influence reaches way, way beyond its own dusty surface. It possesses a gravitational pull that physically links this quiet, airless world directly to our everyday lives. But the truly poetic realization here is the dual nature of that force. Think about it. The exact same gravitational mechanics that Mission Control leveraged to slingshot the Artemis II capsule around the moon and safely bring its crew back home, well, that's the very same gravity pulling on our oceans, creating the tides that crash against our shores every single day. The moon is a world of incredible duality. Physically, it drives those ocean tides, this massive planetary rhythm we beat to constantly. But on a human level, it remains a constant glowing presence in our skies that has driven our ambition for millennia. I mean, ancient navigators used the position of the moon to bravely chart paths across totally uncharted oceans on Earth. And today, Artemis navigators are using those exact same celestial mechanics to chart paths across the uncharted oceans of space. It beautifully bridges our deepest ancestral history with our most cutting-edge exploration.
Which leaves us with this final thought to ponder. We've finally gone back. We've successfully flown humans around the moon again, breaking a 50-year silence. So, as Artemis II paves the way for our permanent, sustained future in space, what new secrets will this quiet, airless world eventually reveal about our own everyday lives? Thank you so much for joining me for this explainer. Keep looking up, stay curious, and I'll catch you next time.